All right, welcome back to another example using u substitution to solve some integrals. Now in this case, our integrand here is 2x plus 3 all squared times x, and we're going to take the integral of that basically, and the question is, find the solution to this integral, integrated. Now in this particular situation, we have our integrand containing a power of an expression. So the expression that's raised to a power is 2x plus 3, that's all squared. And in situations like this, it's good to try a substitution where u is equal to the expression that's being raised to a power. So for us, we're going to write that u is going to be equal to 2x plus 3. Now always with u substitution problems, we're going to take the derivative of u. So we're going to have du dx, and that's going to be the derivative of this, which is just going to be equal to 2. Now we want to rearrange for dx here as well, so we just also get dx is equal to du over 2, simply just rearranging this formula here. And then we also want to isolate for dx, so simply bring it up here and bring the 2 down. So we're going to have dx is just equal to du over 2. All right, so let's plug this stuff into our expression and see what we get. So we're going to have the integral of, we're going to make the swap here for u, so we're just going to have u squared, and then we have an x, and then for dx we have this expression which is du over 2. Now we can pull out the constant if we want. Right now we could wait later, but we're going to have this is equal to the integral of u squared x du. And this is a point where we have to stop and think about what's going on, because now we have an integral, but we have a mixed one with u's and x's, and this is not going to work for us. So what we need to do is we need to get rid of this x. And to do that, what we want to do is we want to come back up to our original equation here for u. We want to reorganize this one to have it in terms of x, basically to isolate x on one side and put everything else on the other. And if we do that, we're just going to get x is equal to 1/2 times u minus 3. So now what we can do is we can bring this x, basically all the stuff, and we're going to substitute it in here for this x. So this is equal to 1 over 2 times the integral of u squared times 1/2 times u minus 3. This is all du. All right, so we can bring out that half again. So we're going to have 1 over 4 times the integral of, now we're going to have u cubed minus 3u squared, and that's all du. And when you have situations like this where we're taking the integral of two separate terms, it's generally easier to separate it into each term into its own integral. So let's just write that as 1 over 4 times the integral of u3 du minus 3, we're going to pull out that constant, times the integral of u squared du. And if you look at these integrals and you know how to solve them now by memory, that's okay. You can just do that and jump straight to the solution. But if you can't remember, we can look at the table, which is right here. And I'll put a link to this in the description below where you can get it. And this is basically just a link on the Engineer for Free website. And then there's also a PDF version that you can download and print off if you want. But this is just pretty much a typical table that you would find in a Calculus 2 class or be given to as a formula sheet for an exam. But basically we're looking here for ones that would have the form like this: x to the power of n dx is equal to x to the n plus 1 over n plus 1, and that's all plus c. So this is the substitution that we're going to make basically for our integrals that here have x to the power of n. In this case, we have u to the n, but basically n is going to be 3 in this term, and n is going to be 2 in this term. So let's maybe come up here and give ourselves some space to continue working. But we're going to have, I just see it, this should also be a 1 over 4 times 3. Okay, carrying on. So we're going to have 1 over 4 times u to the power of 4 over 4 minus 3 over 4 times u to the power of 3 all over 3. And this is all plus one single arbitrary constant. Each term actually gets its own arbitrary constant, but if you just add two arbitrary constants together, it's still just some arbitrary number that we don't know, so we can just combine them all into one, and that's pretty standard. So we can just simplify this a little bit, tiny bit more before proceeding. So we're just going to have like 1 over 16 times u to the power of 4 minus 1 over 4 u to the power of 3 plus that arbitrary constant. And then all we need to do now is just resubstitute back in what we have for u, and u is up here, it's just equal to 2x plus 3. So we're going to put that in here, and we're going to put that in here. So we're just going to have 1 over 16 times 2x plus 3 all to the power of 4 minus 1 over 4 times 2x plus 3 all to the power of 3 plus our arbitrary constant, and that is going to give us our final answer to the original problem, which was basically finding the solution to this integral. So yeah, that's how you're always going to do u substitution problems. Basically, figure out what you want to substitute. In the case where we have a power of an expression, that makes a really good candidate for subbing that whole expression as u. Take the derivative of u with respect to x, reorganize for dx so that we can also swap that out in our expression. And in the case where you do that stuff and you come halfway through the problem and you realize you still have a mixed integrand with u's and dx's, then come back to your original expression for u, reorganize so you isolate for x, and then take that x, swap it out with the x that you see in your equation, and that's going to give you just u's, and then proceed. And then at the very end, don't forget to re-substitute back, put the whole thing back in terms of x, and you will find your solution. So anyways, I hope it helped. Thank you very much for watching, and I will see you in the next one.